Hey robot makers, do you want to learn how to set up an NVMe drive on a Raspberry Pi 5 with a Pimoroni base? Then this and create the ultimate NAS, I should add, then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get to our show. I'm going to turn down the volume of my notifications there because they always seem to get in the way there. So we're going to do things a little bit differently this week. We're going to go through how to install this Pimoroni base, the NVMe base, with a brand new NVMe drive. But we're going to do this kind of first. We normally do the demos kind of after all the show and tell stuff. We're going to actually properly show it this time, and that's simply because when we get to the bit where we install the OS, it might take a little bit of time, so therefore if we just mix up the order, it won't take forever while you just sit watching a progress bar to complete. So what we're going to cover at today's show, we're going to learn how to install an NVMe drive and set up a NAS with Samba. Lots of acronyms and words there that we'll explain in the show. So we're going to explain what an NVMe drive is, what those letters stand for, what it can do better than a USB drive, for example. We're going to look at how to install the Pimoroni NVMe base, which is a brand new board which goes underneath the Raspberry Pi. We're going to install the Raspberry Pi OS so that it actually boots from the NVMe drive, and then we're going to set up some file sharing with Samba, which is a file sharing system for Raspberry Pi and Linux. And then we'll have the usual live stream Q&A mailbox at the end of the show as well. Okay, so like I said, we're going to do this a little bit differently this week. We're going to actually go to the demo straight away, and that's just so that we can get the installer going and then look at some other bits and pieces. So over here on my desk, on the captain's table, as I usually say on the Pim videos, it's got a nice little USB drive that I loaded the OS on, just so that it's cached actually on this drive already. That should save us a little bit of time. So I've already got a Raspberry Pi 5 here. This one is a Pineberry Pi hat. And you can see there, this has got a 1 terabyte drive on it, and this one fits quite neatly into the official Raspberry Pi case. So you can just see the little connector there that connects into the PCIe bus there. So that one's already set up. We're actually going to do a fresh install. I've got a Raspberry Pi 5 here that's running. If I go over to my overhead there, for example, this is actually the Raspberry Pi 5 up and running. If we go to the let's just go to the terminal, and if we just do df-h, that shows us our disk full, and you can see there we've got 18 gigs free at the moment. We're using probably just a couple of gig on this drive. It's quite a fresh drive, there's not very much going on there. So that's essentially just one, probably a 32 gig card, the SD card. Okay, so let's get back over to our overhead. So what I'm going to do, I'm actually going to unplug the keyboard, the network cable, the power and the video, just so that we've got the drive nice and accessible. It's quite warm, that. And we're going to install the base, which is actually going to go on the underside. You can just see the SD card there, yes, 32 gig. And that's the PCIe connector that we're going to be connecting the drive to as well. So I've got a couple of things here to look at. We have the Pimoroni NVMe base, which is being shipped out to people now, as I understand. So there's the actual circuit board, and then we get a few other bits and pieces in here. We get a very important little cable, which is the one that's going to go between the board and the Raspberry Pi. That's everything out of that bag. And we've got this NVMe base, which you can see there's a circuit board. It's got two important things. That's the connector that's going to connect to the Raspberry Pi 5, and this is going to connect to the NVMe drive itself. And then there's a number of holes with some markings on there for different sizes. We'll talk about that shortly. And we've also got the 4 mounting holes for the Pi to connect to underneath. We've also got some nice little rubber feet, and we've got a packet of screws and nuts and things. So I'm just going to tip these out just so that I can easily get at them. So we also have here the NVMe drive itself. This one is a 1 terabyte drive. I did open this before just to check everything worked okay. I've not installed anything on it just yet. So I'm going to be very careful not to touch those edge connectors that are just there. If I just hold this up to the camera, you can just see though there's about 5 little connectors, and then there's a whole bunch of other ones. So that little gap there helps us orient on the drive where this is actually going to connect into. So I've gone and earthed myself already. So the first thing you normally do is you angle this as you push it in, and that just helps it sort of key into place. And you can see there it sort of flaps about a little bit. So there's this little half moon kind of area here, what we want to do is we want to put a screw through that. So one of these nuts is nuts and bolts. One of them is slightly longer than the rest. So what I'm going to do, yeah, this is going to be an episode where I drop a lot of stuff. So we need to build that drop counter, don't we? So what I'm going to do is just put one of these little nuts to hold that in place there. You can also see the beautiful artwork on the back of the drive there. NVMe base for Raspberry Pi. Now some of these have a type one. I think the early ones have they have no is it no B, so it says Raspberry. So if you've got one of those, that's probably a collector's item. That right, so that's now screwed in, that's not going anywhere. That drive is now connected to this this base. So the next thing we need to do is quite a quick thing to do. So I'm just going to push these little screws through the hole, get the standoffs, which are these little hexagonal nuts, and just quickly push these into place. So I think Paul has done a really nice video on Pimoroni's website of how to set these up. So when you're buying them, you can see in sort of slow time all the thoughts from the people that actually made this. So I'm just trying to rush to put this together so that we can start to install the OS on it, and then we can move to the interesting part where we set up the NAS. So I've just installed those 4 standoffs on the base. There we go, like so. And what we can now do is there's this little connector that's just here, and this is, let's get that to focus, and this has got a little hinge on it. So if I just very gently prise up, you can see that it sort of moves around as a little hinge, and we can get this and we can put this so that the sort of shiny side down, that's going to push into the little connectors there, and then we just push that down into place very gently so we don't break it, and now that's secured into place. Just going to make sure that's sat nicely. There we go, I think it just moved ever so slightly as I moved it. Right, so that's now locked into place. You can see now that's what the half-finished article looks like. So what we're then going to do is get our Raspberry Pi 5, and we're going to just line up the drive and the Pi. Now the easiest way to install this now is to get your Pi 5 and very gently just nudge that up so that's open. I've broken so many of these on the camera modules just by being a bit too uncareful with them. So once you pull that back, just make sure that this is going to go the right way around. There we go. So this is going to connect with the shiny side pointing to the USB drives. Let's just push this into place. This is probably the toughest bit of the video, especially when you're trying to do it and get everything in shot. So I'm just going to push that connector into the drive, and then once that's in, we then just press those. I was trying to Google what these things are actually called. Cable locks, cable clips. This bit that I'm pushing in at the moment, what is it actually called? Right, now that that's there, we can swing that round like so. So you can now see that's connected up. It kind of goes at a little angle, which is quite cool. And now we can finish off the install by just putting these screws into place. So put a screwdriver just here. There we go. And let's just do the other one. There we go. Just for completeness, I'll do the rest of them. So obviously this means that it's not going to fit nicely in the Raspberry Pi official case, but it does mean that we can put any of the things into the pin headers there, so it's not getting in the way of that, which they got around that on the Pimoroni Pi one simply by having it actually extra headers on the hat itself, but it does mean that that's quite tall now, but they did engineer it so it goes in the official case, which is quite neat. Right, there we go. Got this screwdriver from Maplin's, and look what my dog did to it. That's Minnie. She found it and chewed it. It's my favourite screwdriver. Okay, so that is the drive ready to go. So what I'm going to do now, I'm going to leave the SD card in place for now. So that's still in there. You can just see the SD card. And I'm just going to plug in some power. I'm just going to sit it in here just so that it doesn't short anything out. We can see now it doesn't fit nicely into the case anymore. So let's just plug in all the USB things first. Let's plug in the video. This is going to my capture card. And let's plug in some power. Okay, we should see that spin up in a second if I've done everything correct. Yep, there we go. And if I now go over to, let's go back, I'll go back to me, and then I shall press this button here. Yes, you can see up in there, that corner of the screen there, that's the video from the actual Raspberry Pi booting up. So it's booted up quite nicely there. Okay, so actually I can go over to that now, full screen like so. So I've got a couple of, I've got Wi-Fi and I've also got that Ethernet cable plugged in, and I'm capturing the video by a capture card just so that we can see what's going on. So the first thing I'm going to do now, I'm just going to click on Accessories, Imager, and then I'm going to load up the operating system onto this new drive. So I'm going to choose the OS, which is the 64-bit one, and I'm going to choose the storage. So if we can't see the storage there, that means that we need to make some changes. The easiest thing to do is to do a sudo apt update. I'll show you what that looks like. So we open up a window. If we do sudo apt, not spy, apt update, that should bring on the latest versions of all the files. And if you do a sudo apt upgrade, any files that need to be installed will then get suggested. I've already done this before the show and given it a reboot as well so that it has the latest firmware ready to go. So that's the drive. You can see 1 terabyte. I'm going to click next. Let's edit some settings. So let's set the host name to be, let's call this one Devo2. Let's set a username and password. Let's set a password there. Let's configure our wireless LAN. So I'm just going to type a password in there as well. And let's set a locale as well, why not? So look at these services. Is there anything that we need to set in there? Yes, let's definitely enable SSH. That helps us log in, and let's have a look at the options. That's fine. Okay, let's click that and let's apply those customizations. Let's initialize and erase. And we just need the password, which is the password of this Pi. I think that's it. There we go. Right. So that's going to take a little while for that to do. So while it does that, I'm just going to come back over to our slides and we're going to have a look in slow time about some of those things that we've just covered, because this is the bit that takes the longest time and there's nothing I could do to speed that up. So what is NVMe? You might have heard this term and just taken it for granted. That's what it's called. It actually stands for non-volatile memory express. So the express is a bit like PCI Express. That's where they've stolen that term from. So this refers to memory that retains data even when the power is turned off. So if you think about regular RAM that you have in your computer, as soon as you switch that off, the RAM gets erased. All the programs that run in disappear. So if you've not saved something to permanent storage, you will lose that. So NVMe is non-volatile. It will stay once you've turned the power off. That's essentially what that means. And the express part, like we said, is borrowed from PCI Express, which is what we're actually using to connect this to the Raspberry Pi 5. And that's a very high-speed peripheral component interconnect, the express version, high-speed interface for common computers. So just having a quick look at some comments about the bandwidth. So hopefully that will recover shortly. I can just see that some people are getting dropped down. It'll probably buffer for a little moment and you'll just have to just pause it and let it catch up. If you just refresh your browser as well, that also helps for the people watching this live. So yes, NVMe was specifically designed to unleash the potential of solid-state drives, which were a bottleneck for older interfaces such as SATA. And that was designed for slower spinning drives where you could actually wait a bit of time for a cache to fill up. With these kind of drives, it's so fast, this no longer becomes the bottleneck. The bottleneck was actually the interface itself. So what is NVMe? So there's a few different standards for this. They usually are built into the SSD drive itself. In these cases with the NVMe, they just have the connector at the end, and that most common connector is this M.2 connector. So they are very small, very compact, and that's why you'll find them in things like laptops and personal computers as well. U2 is the pop boop, but it's also a name for a standard of a slightly larger NVMe drive, the SSDs, and these are often found in enterprise and server environments as well. So they're sort of physically similar to the 2.5 SATA drives, but with a different connector for that high-speed performance. Then you've got the PCIe adding cards. These are usually just called AIC cards, or AIC. The card at the end would be redundant, I guess. These are full-side cards that slot into your motherboard of your computer via a PCIe slot. And then we have this NF1, which is the next generation form factor as well. And again, that's designed for servers and data center usage. So each form factor is designed for a specific use case. Most commonly you'll find in our kind of hobbyist and desktop consumer space is the M.2. Oops, thanks Vince. Vince has just become a member there. Thank you very much for that. I'm just going to switch off the stream elements just for a moment, just so that we can do the main part of the show. I'll switch them back on when we get to the Q&A section. So there's a naming convention. You'll see that these NVMe drives have a name which is 4 numbers usually. So these are actually the dimensions of the board. A bit like 18650 batteries are actually to do with the dimensions of the battery. It's the exact same thing with NVMe drives as well. So 2230 would be the 22mm by 30mm size. I think we're using the 2242 for this particular show. And you can see that's quite a small size, just about the right kind of size for a Raspberry Pi. But you can go up to the 2280 on the Pimoroni board as well. They support quite a few of the sizes. I think there's about 4 or 5 sizes that they support there. Okay, let's go to the next one there. So installing the NVMe drive on the Raspberry Pi 5, as you've seen, it's quite simple, straightforward to do. So there's 4 steps to this. We're going to install the NVMe drive on the board. We're going to install the OS onto the NVMe drive with the imager, which is what we're doing currently. So you have a quick look and see how that's going. So if I just swap over to there, you can see I just need to type in the password there. Perfect. So that one is ready for us in a moment when we've finished our main slides, which is good to know. So once we've done the installing of the Raspberry Pi OS onto the NVMe drive, we then need to change the boot order, because if we don't do that, it'll still try and boot from the SD card or the USB connector or the network, and there's a sequence of those. So what we want to do is bump up the NVMe drive to be the first one that it is an option to boot from. Then we can remove the SD card completely, and that means we can then have all that speed and power and capacity of that NVMe drive. So unpacking the base, as you've seen, is quite straightforward. We have this nice PCB board with 2 connectors on it there and a bunch of holes which we've used to connect to our Raspberry Pi 5 underneath. As I said, as I was unpackaging it, make sure you earth yourself. If you have a computer with like a metal case, like a Mac for example, just touch the metal just to make sure you earthed yourself. But if you have any kind of static electricity that you've been generating as you're moving around by your clothing or just by picking up from other objects, that can actually get transferred to the memory and damages it. It essentially gives it electric shock and can damage it. So you don't want to touch the edge connectors. Really try and handle it very carefully. If you can earth yourself, do that first. So next up, you'll see this little slot that along the one side of the NVMe drive, with a little notch that keys it into place. Make sure you get that the right way round and that you are putting the drive in the correct way. Don't try and force this. Or if you've bought an NVMe drive that's the wrong size for the board, you'll notice when the notch doesn't quite align properly, that probably means you bought the wrong one. So you probably need to speak to your supplier about that if that happens. So you want to put it at a slight angle. I did it about 30 degrees and then pushed it down, and then there's a little retaining screw, and on this case there was also a nut we attached underneath, and that meant that could then be secured into place. And that just means that the drive isn't going to pop out if you move the Pi around, and it means all the connections are sort of electrically sound. Next, we installed all those standoffs. So there's a couple of screws. It does actually come with some longer screws. So this is in the Pimoroni NVMe base pack. So you can see they've got these longer screws. I think they're about 12mm, something like that. Or they have the short ones, depending how you want to configure your Pi. If you've got something else that this is going to screw onto, there's a rather than having 2 screws going into the standoff, you can have one long one go all the way through and then have something else that connects to the Pi on top. So if you've got a hat, for example, that needs some standoffs, you could have kind of layers and layers of sandwiched together like a Big Mac of standoffs. So they just securely lift the Raspberry Pi above the base and allow some air through and a kind of solid physical connection all the way round. So once we've done that, we can put the little screws in. In our case, this is what we wanted to do, so that the Raspberry Pi 5 is held into place as well. Once we've done that, we can then attach that little cable. That's probably the fiddliest bit, but it wasn't too hard. You saw me do it just then. And this is what I was saying about those little cable clip connectors. So you need to sort of prise that one. It opens up like that from the base on the Pimoroni base, the NVMe base. But other ones, I think the Pimoroni Pi one, that one, I can't remember what that one did actually. I think that's the same. That one also hinges up as well. Just makes a nice connection. So don't force them, just very, very gentle with the can snap very easily, and then that's it. It's very difficult to actually replace that because it's part of the plastic that's attached to the motherboard, attached to the PCB. So once we've done that, we can then close that, lock it into place, and then your cable is not going to go anywhere, and you've got a nice solid connection there. So next we need to change the boot order. So we're going to do that right now. We're going to run this rpi-eprom-config and then space-e. That's going to edit it. And then we simply need to change this boot order and add a number 6 to the end of it. So let's do that now. Let's go back over to our Raspberry Pi 5, which has just finished. It says we can now remove the SD card from the reader. In this case, it's actually the NVMe thing, the card that is in there already. So what we want to do now is run that RPI EEPROM, I think it's config, and then space-e. Oops, and then we need to run this as root. So let's do sudo there. And we've already got boot order there, so I'm just going to add the number 6 to the end. That's actually a hexadecimal value there, that F416. And that's actually the sequence of which the drive is going to boot in. So once we've done that, I can do Control and X. Yes, to save the buffer, return. And you can see there now it says there are pending updates. And what we need to do now is just do init 6. In fact, we could do instead, if I go to the overhead camera, what we can actually do instead is press the power button, press and hold it. You can now see that the machine is now shutting down. If I go back to the overhead camera, you can see now it's now powering off. There we go, and it's now completely powered off. So what I can now do is I could remove that SD card. I can do this without damaging it. There we go. So that's now taken out. And if we now power the Pi back up and head back over to the overhead, we should see in a second that this will now power up and everything hopefully should work okay. It's giving me a bit of a flashy light there. That doesn't look good. Let me just have a quick check and see what's going on there. We just power that off. So I think red means bad. So let me just power this off for a second and then power that back up. Let's do that. So if I go to the overhead, just so you can see what I'm actually doing there. So I'm just going to power this back on. Like so. If I do that, there we go. We should be able to see everything that's going on at the same time. You can kind of see me leaning over. There we go. That feels better. The fan has come on. Not sure why it's messed up for a second. I'm just going to let that, there we go. If we now go back over to the overhead, we can see now. So what's it saying? Failed to open SD card, which we know. But it isn't booting from the drive, importantly. So let's just see what it says there. Boot mode, USB. So I think I know what's going on here. So let me just go back to the main camera. I'm going to put the SD card back in, so I'm just going to unplug the power on here. I just want to show you what I'm actually doing there so you can see. I'm just going to plug the SD card back in so we can actually boot from that. Just to finish the job off. I think there might be an update that we need to run or something that we need to back in focus. There we go. We might just need to do that BIOS update. Some drives need this, others don't need this at all. So let's just wait for that to power up. Let me just press that on. There we go. Plug the power in, that helps. There we go. And just press the power on. And I wanted to show you any kind of thing that happens like this because this is what today's show is about. It's actually getting this thing to work, because some drives are different. This Pimoroni Pi one, I didn't need to do any kind of fancy update for that. That one simply just plugged in and away we went, and it was fine. So just going to wait for this to boot up. It's quite quick to boot off the SD card anyway, so we're not going to be waiting around too long. Okay, let's just see what it comes up with there. And while it's doing that, I'm just going to go back to our show notes for a second. So we did the sudo rpi eprom config-e. What we'll now do is just have a look and see if there's an extra command that we need to run to get this to work. So I'm just going to go back over to the Pimoroni website and just check on anything else that we need to do to get this up and running. I'm pretty sure it's the same actually. So there we go. So I think if I go to there now, yep, so the Pi's booted up okay. So let's go and have a look and see what we need to do next. So I'm going to open up a terminal. I'm just going to run that command again where we did the sudo rpi-eeprom dash, and then it was config, was it? Update it was. Update-e. Okay, so I did config-e and this is now update-e. So what that will do is actually force that any updates that are required will actually get updated there. It's also saying there Raspberry Pi 4 for CM4, CM4S and Pi 400, the flash ROM updates are not enabled by default. Okay, so there is some additional things that we can try that are on the Raspberry Pi, the Pimoroni website, but I'm just going to try this now because I think by doing that update, that'll get us where we need to be. So I'm just going to let that to do its thing. It's going to get back to me for a second because that looks ugly with all those bars on there. It looks like the YouTube channel's crashed or something. Now you don't actually get a speed boost on boot time when you put an NVMe drive in, surprisingly, because the actual delay of loading all the software into memory is the sort of sequence of updates is actually part of the Raspberry Pi's update process. So actually putting in a faster drive doesn't actually make the boot up faster, but everything else is a lot faster. Right, okay, so I think we probably now have booted from that new drive. So if we now go back over to the overhead, which is now here, let's have a check and see if I now do disk free -h. So we're now still booting from the Raspberry Pi's SD card. So I'm going to try again by removing the SD card and seeing if there's any issues there. I'm also going to see what that update is that it seems to think it's got there. So I'm just going to let it install those. I did actually do an update before, so I'm not sure why that's the case. So type in my password. Is that it? Oops, wrong one. Interesting. So when I typed in the password then, that proves we're actually running off the brand new NVMe drive. So if we look on there, NVMe, and look at the free space, the space available, 887 gigs. So that's actually telling us that we have the new drive installed and we've actually booted up from it as well. So that's a success. All I needed to do was do that RPI update rather than the config. So if we go back to that terminal for a second, oops, using the wrong mouse there. If we go back to that terminal, I'm just going to type in the history so we can see what commands we've typed in there. So I did that RPI-EPROM-update-E before I did config. And config allowed us to edit the file. So if I go back in there, I can show you how to do this. We go back in and we change that to be config-E. We get the editor where we can actually edit changes. And when you come out of this, even if you say no, it will still say that there are pending changes. So there's a command there just on the bottom line that says, if you want to actually get rid of these updates that you've just put in, you can just do -R to remove them. So those temporary files have now been removed. That was just me demoing it. So I think those updates are probably nearly installed. We're going to go back to our slides, and once this is done, we can then set up Samba. But that's good. That means we can carry on with the show. Things are working as we expect them to. Great. So we're now booting from our new NVMe drive. So installing the Raspberry Pi OS on the NVMe drive, you saw that it was quite a straightforward process. I'll just talk you through it now in a bit more slow time. So the first thing we did, on the booting from the SD card on the Raspberry Pi 5, running the Raspberry Pi OS, the latest version, I went to the Pi menu, accessories, and then Imager. And Imager booted up, and we can have a look at what that looks like now. There's 3 buttons on here essentially. So the first thing we do is choose the device. So this is a Raspberry Pi 5, so we selected the Raspberry Pi 5 option. The reason they've done this is to try and simplify the sort of tree of choices you need to go through to guide people into the correct OS for their computer, because if they have a Raspberry Pi 1, for example, and they're trying to install the latest version of Raspberry Pi OS on there, the 64-bit version, that won't work, so they need the 32-bit version. To prevent all those kinds of wrong choices being made, they've added these extra steps. So we're just going to choose the Raspberry Pi 5. We're then going to choose the operating system, so it'll say which OS version do you want to install. We're going to go for the 64-bit version, the default one, Bookworm. This is the December the 5th, 2023 version of Raspberry Pi OS. Once we've selected that, we can then choose that storage button. I didn't have screenshots on this when I was doing the test of this, so I couldn't actually screen grab them to show you this. So yes, we choose the NVMe drive you saw just on the video, me doing that. We click the next button, and then it will download the Raspberry Pi OS and burn it onto the NVMe drive. Once it's finished doing that, we can then do an extra step. Now it says on there you can turn off the drive, remove the SD card, but before we do that, there is actually that extra step, and that was this changing of the boot order. So I made a bit of a mistake on that one, and you can see on here we do the sudo rpi-eprom-config -e. I think that's for edit. That edits the configuration. We can put that 6 on the end of the boot order, and then once we've done that, we can then just do the update command. So the config command first, and let's actually go in there and add the extra command that we needed to have on there, because I missed that out. I want this to be sort of complete, so we had on there update as well. There we go. You saw the magic then behind the curtain. So there we go, that's the extra command that we needed to do. So there's config to edit the file and update to actually make that happen. So if you like what I do and you want me to grow the show more, please make sure you give this video a like, drop me a comment, let me know if you have a Raspberry Pi 5 and if you're intending to get a hat or a base or both on different machines. Let me know what your choice is. And if you haven't subscribed to the channel already, please do me a favour. It means an awful lot to me if you do this. Subscribe to the channel. It costs you absolutely nothing, and it means you'll get notified when I do new live streams and new videos. And I do go live every single Sunday at 7 o'clock GMT. And you can join in the chat at the end of the show as well. So let's get to installing Samba and setting up some file sharing. This is really straightforward to do compared to the rest of the show. So Samba is actually one of these backronyms. SMB is the send message block. It's a protocol used by Windows machines initially to send files between each other. It's quite an old protocol. But it's been picked up by the Unix crowd and also the Mac crowd. They've also started using this. There used to be all different types of file transfer protocol that were used, like NFS for the network filing system for Unix. Apple had their own AFP. They had the Apple file sharing protocol. They've all now just basically settled on the one that Microsoft developed years ago, which is Samba SMB. So you can see down the logo SMB with the A's in between. That's where we get Samba from. Just a piece of trivia there. So what we need to do is we need to install the Samba and Samba common binaries. Once we've done that, we can then set up a folder that we can share. We just need to change some file permissions on there, and we do that with the chmod, which is like the change mode of the file. We're basically saying +R, I think there should be a capital R, and that will basically recursively change any files that are in that folder already. But we're going to create a new folder called share. We're then going to share it. 775 is I think it's octal, if you're interested, rather than hexadecimal or binary. And basically that sets the 3 different types of permissions that you have in the Unix world. You have world, group, and user, and they're in sort of groups of 3. So we're going to do that. So let's go back over to our Raspberry Pi and let's install Samba and then set up a new folder to share. So I'm just going to click on that. So first of all, we'll do sudo apt install Samba, and then there was Samba common -bin, I think. So let's hit install that. I'm just going to say yes. This is where the new Raspberry Pi 5 is so much quicker at installing things than the previous generations, compared to this is almost like 2-3 times faster than the Raspberry Pi 4 installing things. So satisfying to see how quick that is. Okay, that's Samba installed. So what we need to do now is we need to create, so we'll do make directory, a folder that's called share. So if we do ls for list, we can now see we've got a folder that's called share. If I do ls-l, it'll list it long, and that will show the file permissions that we have. So D stands for directory. We've got read, write, execute, read, write, execute, read, write, execute. We've then got the name of the owner of the file as well. So what we need to do is change that the mode of the file, which is these file permissions. We're going to say -r for recursive. We're going to say 775 and then the name of the folder that we want to change. So if we now do the ls-l again, we'll see that now we've got some extra write permissions for the group, which were missing from the previous version. So that 775 essentially sets each one of those like so. Okay, so what we need to do next, we go to our etc/samba, I think it is. Let's just list that. Yes, we've got a smb.conf, so we need to edit that. I'm going to do nano, and then etc. Samba. Typing this and looking at the screen at a funny angle. That's why it's taking me a second to do that. And then smb.conf. Okay. And if I scroll down to the very bottom of this file, it says it's unwritable, so I just need to exit out of that and do sudo at the very beginning of that. That'll just help me write to it. There we go. We can now write to the file because we're a super user. So the very bottom of this file, I'm just going to add some extra bits and pieces into this. So what we're going to do, I'm just going to get this on my screen so I can see it. So if you want to follow along with this tutorial, back over to me for a second, I've actually written all this up on kevsrobots.com. So if I just show you what that looks like, you'll be able to see what I'll be following along with. So there's an article, I think it's currently on go to the blog section, how to install an NVMe drive as a NAS server. You can see there we've got how to set up Samba on a Raspberry Pi 5 there. So it's got all the different steps you need, step by step. So we basically just edited the SMB file, and basically we want to copy all of this now onto that text file. So I'm just going to load this up on another screen so I can see it, and then I can do this and show you at the same time. Right, so I'm just going to go to there. There we go. Right, let's go back over to the Raspberry Pi. So I'm going to create a new section down here. So we start out with the name of the share that we want to give it. So I'm just going to call this one share. Use those square brackets to encompass it. And then we can give it a comment. This appears kind of on the, when you're sort of browsing the drive. So we can say, we'll call this one Pi share folder, something like that. Okay. We then need to say what the path of that folder is. So path equals, and we need to give it the full path. So home / now on this particular Pi, my main user is called Kev. If I go up to the terminal and just open up a new terminal and do the command pwd, which is like the current working directory, you can see home Kev is where all my files live. So I'm just going to move that. Let's move that up there, for example. So when I'm telling it where this shared folder is, it's actually in home Kev and then share. So next we need to say whether it's browsable. So this means if you're looking from another computer like a Windows or a Mac computer, is this actually browsable? So we're going to say yes. We can then say, is it writable? Yes. We can also say only guest. Now the idea of this is sometimes you might want to have like an anonymous folder that's only accessible to guests but not other people. This isn't the case in this one. We then have a thing called a mask. So before, when I set those the 0775, they're the file permissions. The mask is essentially the file permissions when it's creating new files. So the create mask looks like that, and the directory mask. Oops, type that correctly. Directory mask. Sorry, typing on one computer at a funny angle and looking back at my other instructions on the other screen, so it's a bit awkward this. And then public, we can say yes, the public is whether this is accessible by everyone or not, and we can even say guest okay in this case. We're going to be very permissive in this case and just let everyone access it. Right, that's it. I'm going to do Control X to say I want to save the file. Yes, I want to save it with the Y key, and then enter to exit out. So that's now been added to our Samba configuration. We also need to add in a user for our Samba. So we do sudo smb passwd, and then we're going to do -a to add to this, and I'm going to add the kev user to this. I'm going to create a new password. Type that password in again. Okay, the final thing we need to do is restart Samba. So the way that we do this, we do Samba system control ctl restart smbd, which is the Samba daemon, like so. Right, if we now go over to a different computer, so I'm going to go over to the Mac. I'm just going to find it and then show you on the screen. We should be able to now discover this on our network. So we called the machine dev2, didn't we? Yes, so if I now go over to here, these are a couple of machines. You can see Alex's network there. Dev2 is the one that we've just created. We can see we've got two shares. We have share and we have kev. Kev is my home folder, but also share is the one that we've just created. So if we now create, and we can see there, almost a terabyte free, which is good because that's what we created. I can actually go back over to that Raspberry Pi computer. I can use the touch command to create a file. Let's call it readme.txt, something like that. I now go back over to my Mac, like so, and let's just see if I just go out of that and back in, we should see that readme file appear momentarily. I don't know how quickly it updates this. I'll just resize the window and see if it'll find that file or not, as the case may be. Maybe we just create something in here as well as test, something like that. So you can see there we can copy files across. I'll copy a file. In fact, let's think about this. Let's go open up a text editor, and I'm just going to save a file into the drive as well, just so we can see that that works both directions. So if I just go over to here, let's do hello world, file save, and then I'm going to save that as, let's go down to dev02 into share, and I'm going to call this one file from mac.txt. Let's use RTF, actually, rich text format. Okay, so that's now appeared there. So if I now go back over to the Raspberry Pi, let's go back over to the Raspberry Pi there, and let's do ls. Let's go into that's why that file didn't appear. I wasn't actually in that correct folder. If I just move that file mv readme.txt, let's move that into share, and then let's do change directory to share. That's why we couldn't actually see that in there. And then do ls. We should now see, or ls-l. We have the file from the Mac. We've got the readme.txt. We've got that test folder as well. So that now means that the file sharing is now set up, and we can now see that on the Mac. If I go back over to the Mac there, you can see now I'm connected to the share. I can see that readme.txt that we created. So hello back. Save that. And let's just go OK, and there we go. So we've now set up file sharing, and this means that we can connect to this from our phone. When I show you my phone there, basically you can go to the Files app if you're on iOS. You can find this on your network because it's kind of showing where it is. You basically just even need to know the IP address of the Mac. It's already doing all that kind of broadcasting and stuff in the background as part of that SMB protocol. So it actually works. I'm so pleased how simple that was to do. Now that might have gone over your head, and that's why I've written up some of this information online, so you can do this slowly in your own time. So there's the configuration that we added to that configuration file, the SMB configuration file on our Raspberry Pi. We created a new header section, which is what those square brackets are. We created a new comment, which was the Pi shared folder. We told it what path to share, which is the home, in my case, kev/share. And then we set the options. You can just basically choose these default ones if you wish. Or if you want to know more about this, you could basically just Google Samba and understand what all these different settings actually mean. But they're pretty permissive as they're set up there. And then we added the new user, which was the SMB password-a, and then in my case it was Kev rather than Pi, but added my user account to the SMB database of passwords that's allowed, and therefore we could, when we connected to it over a network, we were able to sort of see that shared drive automatically. Everything just worked. So if you want to learn more about robotics, Python, Raspberry Pi, I've got all kinds of courses, all completely free, ready for you to learn right away on kevsrobots.com/learn/. I've actually been updating Kev's Robots in the background, adding a few more features to the website, such as the new search facility, and I've also been tweaking some of the other things just to make it a bit more user-friendly. So head over to Learn and you'll be able to get learning today. If you want to get yourself one of these Robot Maker hats, we have them in all different colours. We've got t-shirts, we've got mugs, all kinds of good stuff. And very soon, we're still working out with our supplier at the moment for the shipping. We've got the Robot Maker's Almanac, and we have the Maker Notes. They're going to be added to the store very soon as well. So check out kevsrobots.com/merch if you want to get yourself that and help support the show. If you've not already joined our Discord server, you can head over to kevsrobots.com/discord, get yourself a sign up link there and join our growing community. It's really quite a large community now. Is it about 200 or 300 users, I think, are on there, Alex? It's quite a lot of people, and I occasionally dip in there myself and see what people have been doing, particularly if they're showing pictures of their robots. If you want to follow me on social media, I'm all over social media, so you can find me at Kevin McAleer at threads.net for threads. On TikTok, I'm Kevin McAleer6. On Instagram, I'm at Kevin McAleer. On X, I'm at Kev's Mac. On Mastodon, I'm at Kev's Mac at mastodon.social. And I'm also on Blue Sky at kevsmac.bsky.social as well. You'll get some behind the scenes pictures, videos, all that kind of good stuff there as well. And if you want to get your name in the credits, you can do that a number of different ways. You can do a super thanks, a super chat. You can join the YouTube membership program. I'm actually going to switch back on the Stream Elements thing there as well, so we can get those overlays going as well. So if you want to get any of those things, you can go to kevsrobots.com/coffee, buy me a physical coffee as a one-off if you like, or if you want to join a membership program, it's essentially the same price of a coffee per month to help support the show and help me keep me in robots that I can keep making programs about. Okay, so that's and there's a couple of supporters I actually want to give a call out to right away. So we have people who bought coffees in the last month. We've got Maria Louise Mayer, who's on the show today. We've got Jason, and we've got a new member today, Alvaro Diaz Gutman, who joined the Buy Me a Coffee membership program as well. We've got Mary Louise Mayer, we have Jeff Johnson, Dean Corty, Marlene Brent, Tom Shemmy and Steve Phillips. And on the YouTube side, we have Alistair Ware, Jean-Paul Jolly, Cassie, Dale from Hybrid Robotics, Tinkering Rocks, JDM, Johnny Bates, Bill Hoy, Orkrad39, Cheerlights, we've got Hans from Cheerlights, Michael, and of course we have Tom as well. Okay. So that's everything I've got for you in the main part of the show. So it's at this part of the video where I'll say thank you so much for watching, and I shall see you next time.